Welcome, ladies and gentlemen. Today we're going to talk about function operations. Alright, let us get started. Make sure you guys have your guided notes, or else this is going to take you a lot longer. So make sure you have the guided notes that I gave to you in class. Alright, function notation. Mathematical functions are often written in function notation. The old way in algebra, which we've used a lot this year too, is like y equals 5x plus 3. Now we're going to use function notation. Function is a given letter of a name, and you are told to input a variable. So we read this, f of x equals 5x plus 3, where the function name is f, and it has a variable x in it. Alright, here we're going to do some examples. When I say g of 4, I'm going to look at this function named g of x, and I'm going to plug in 4 wherever there's an x. So this is going to equal 2 times 4 to the 1/2 minus 6. Now it's going to be helpful for us to remember that 1/2 power is the same as taking the square root. So this equals 2 times the square root of 4 minus 6. So the square root of 4 is 2, so I have 2 times 2 minus 6. So I'm going to get 4 minus 6, which equals negative 2. So g of 4 equals negative 2. So that's when we're plugging in a number for our x value. Now here, all we're doing is we're taking our two functions and we're subtracting them. So my f of x, which is x to the 1/2, minus whatever my g of x is, which is 2x to the 1/2 minus 6. Now I have to distribute this negative here and here, so I'm going to get x to the 1/2 minus 2x to the 1/2 plus 6, because minus a negative turns into a positive. Now here we have to remember back to our exponent rules. Since we have the same base and the same exponent, 1 minus 2 is going to give us a negative x to the 1/2 plus 6. And that, ladies and gentlemen, is our answer. Alright, moving on to the next two. I have f of x plus g of x. When I plug this one in, f of x is x to the 1/2 plus g of x, which is 2x to the 1/2 minus 6. I combine my like terms, so I have x to the 1/2 and 2x to the 1/2. I have 3x to the 1/2 minus 6. Can't simplify this any further, so I'm going to leave it just like this. Our next example is f of x times g of x. So if I look at this one, I have f of x, which is x to the 1/2 times g of x. So 2x to the 1/2 minus 6. Now I have to distribute this x to the 1/2 here and here. So remember, you guys, numbers first. So 1 times 2, I'm going to get 2. But x to the 1/2 times x to the 1/2, I'm going to get x to the first power because I add 1/2 and 1/2. Minus, well, 6 times x to the 1/2 is just 6x to the 1/2. And right there, ladies and gentlemen, we are done. We can leave our answer just like this. Alright, moving on. Example number 5. We have f of x divided by, h of x divided by f of x. So we're going to take our h of x, and that's going to go on top. So I have x squared divided by my f of x, which is x to the 1/2. Now we have to remember our exponent rules, you guys. These aren't going away. It's going to be this number minus this number. So when I subtract the 2, I'm going to get x to the 3/2. We're subtracting them, and we have to leave them as a fraction. We can leave our answer just like this. This next one is a little bit more complex. It says g of f of 81. So what we're doing is we're using our function g, and where there's an x value, we're going to plug in x to the 1/2. So when we look at this, it's going to be 2. There's an x value, so I'm going to put parentheses x to the 1/2, and that x value is to the 1/2 power minus 6. Now I'm going to simplify this right here. Powers to powers, we're going to multiply. So 1/2 times 1/2, I'm going to get 2x to the 1/4 minus 6. Now this is as simplified as we can get, but if we look up here, we're replacing x with 81. So I'm going to have 2 times 81 to the 1/4 minus 6. Now if we remember, 1/4 is same as taking the 4th root. So this is going to look like this. 2 times the 4th root of 81. You can either use your calculator or use your chart. It's going to be on both. And the 4th root of 81 is 3. So I'm going to have 2 times 3 minus 6. 2 times 3 is 6. So 6 minus 6, and that's going to be 0. So my answer for this one ends up being 0. All right, so let's move on. 2 more examples. This one we have the same idea. We have g of h of x. So now we're going to write down our g, and instead of putting x, we're going to put x squared. So I have 2 times x squared to the 1/2 power minus 6. Same thing here, we have to multiply our exponents because it's a power to a power. So I get 2x to the 2/2, which would just reduce to 1 minus 6. This time they have me leave x as x, so we can't go any further on this. This is my answer. All right, moving on. Here we go, f of -2. So we're just plugging in -2 for x. So I have that is going to equal -2 to the 1/2. And we can rewrite this, remember, as a square root. So I have the square root of -2. But we have to stop, wait, and think about this one for a little bit. We have some problems. If we type this into our calculator, we're going to get an error because of this negative sign. So we have to take it out. So we take out the -1. And the 2, remember, square root of -1 equals I. So this one's going to be I times the square root of 2. Very important for us to remember, okay? We can't have any negatives underneath our square roots. All right, moving on. We're going to fill this in. So we can't divide. This is very, very important. We can never, ever divide by 0. So make sure you're filling this in, you guys. These are rules that we have to use. Now, we can't take the square root of a negative number unless we're using I like we did on the last one. Okay. We may not leave our answers with negative exponents. Remember, that's our rules of exponents. We can't have negative exponents. We have to move them if they're negative. Okay. A negative divided or multiplied by another negative becomes a positive. And last but not least, fractions and roots must always be simplified. Okay, we have to simplify. All right, ladies and gentlemen, we are moving on. Here we go. Oops. Also, when we're performing function operations, it's really important to be aware of our limitations. We're going to be talking about our restrictions on our domain and our range. So if I would take both of these functions and I would say f of x divided by g of x, we have a problem here because f of x minus 3, we can only use possible values of x. So which ones will work that's not going to make that 0? If we look at this, the only one that's going to make that 0 will be, anybody know? We're going to talk about it on the next page. All right, here we go. So we have to check out our limitations. We're going to have a lot when we're dividing and when we're taking square roots of things. So if we look at this, we know we can't divide by 0. So for this example right here, ladies and gentlemen, what we're going to do is we're going to say x minus 3 cannot equal 0. So to solve this, we would add 3 on both sides, right? So x cannot equal 3. So when we're writing our domain, so domain It's x such that x equals all real numbers, but, that's really important, x cannot equal 3, okay, because we cannot divide by 0. Let's check out this one. We have g of x equals the square root of x minus 6. Now, we talked about this in the last slide. We can't take square roots of negative numbers, so it has to be 0 or greater. So when we solve this one, we're going to say x minus 6 has to be greater than or equal to 0. We're going to do this anytime we're taking like square roots. So to solve this, we're going to add 6 to both sides. So x has to be greater than or equal to 6. So when we write our domain, we're just going to write x such that x has to be greater than or equal to 6. Because greater than or equal to 6 is going to give us a positive value. Alright, moving on. H of x equals 3x minus 6. Now if we look at this one, we're not dividing by anything, so we don't have to worry about dividing by 0. We're not taking the square root of anything, so we don't have to worry about that. So if we look at this one, there's no restriction, so our domain is going to be x such that x equals all reals. Alright, and we can continue on. If we look at this one, we're dividing. So whenever we're dividing, we have to worry about our denominator. Our denominator cannot equal 0. So I'm going to set 2x plus 3 cannot equal 0. Solve this one, subtract 3 from both sides. 2x cannot equal negative 3. Divide by 2. X cannot equal negative 3 halves. So when I rewrite my domain for this, the domain x such that x equals all real numbers, but x cannot equal negative 3 halves. Alright, ladies and gentlemen, that is all I have for you today. Enjoy the rest of your day, and I will be seeing you soon. Bye!